find the critical numbers of r of x equals x squared times the natural log of x, and then use the second derivative test to determine which give local maximum or minimum values. So we're going to have to differentiate this to find the critical numbers, and we're going to have to use the product rule because this is a product of two types of functions. So for the product rule, we have the derivative of the first, which is 2x times the second, ln of x, plus the first function, x squared, times the derivative of the second. The derivative of ln of x is 1 over x. So we can rewrite the second term as just x, because x squared times 1 over x is x. And we need to know when this is equal to 0 and undefined. Now, the domain of the derivative, this is not defined everywhere because it's got an ln of x in it. So this is only defined for positive values of x. But so is our original function. So on the domain of our original function, the derivative is always defined. So we don't have to worry about this being undefined, but we can set it equal to 0 to get a critical number or 2. We can factor out an x here. So this is going to be x times 2 ln of x minus 1 equals 0. And if we set these equal to 0, the first one we get, x equals 0, is not going to give us a critical number because it is not a part of the domain of our original function. So we can throw that out, and then we just need to solve 2 ln of x minus 1 equals 0. If we add 1 to both sides, that gives us 2 ln of x equals 1, and dividing by 2, ln of x equals 1/2. And if we rewrite this in exponential form, the base is e, so this is e to the 1/2 equals x, and that gives us our critical number. Our critical number is e to the 1/2, which is also the square root of e. Either way, we're good. Now, if we want to use the second derivative test to figure out if this is a local minimum or maximum value that we get, we need to differentiate the derivative to get the second derivative. So we need to differentiate 2x ln of x plus x. If we differentiate 2x ln of x, we're going to use the product rule. I'm going to split this up into 2x times ln of x. So we've got the derivative of the first, which is 2 times the second, ln of x, plus the first, 2x, times the derivative of the second. The derivative of ln of x is 1 over x. And then remember, we also have this extra term of x, and the derivative of that is 1. So this gives us 2 ln of x plus, well, 2x times 1 over x is just 2, because the x's cancel. And then 2 plus 1 is 3. So we've got plus 3. That is our second derivative. And we need to evaluate this at the square root of e. So we've got the second derivative at the square root of e is equal to 2 ln of the square root of e plus 3. Actually, this would have been much better if we had written e to the 1/2. Let's do that. 2 ln of e to the 1/2 plus 3. The reason being, we can take this exponent and pull it out of the logarithm. So this is going to be 2 times 1/2 ln of e plus 3. And we know that the natural log of e is 1, because this is saying e to what power is e? The answer is 1. And we know that 2 times 1/2 is 1, so we've got 1 times 1, which is unsurprisingly 1, and then plus 3. That gives us 4. Since the second derivative is positive, that is concave upward, it's smiling as a graph, and so that means it is a local minimum. So we have a local minimum at x equals e to the 1/2, or we could write x equals the square root of e. Either way, that is the critical number that gives us a local minimum. If we want to know what the function value is there, we can just plug this into the original function, and that would give us the function value, which we could then use towards graphing that function. And we're going to get to that very soon.